Have you ever wondered what the point is behind Terraform outputs? What good are they? Well, that's what we're going to explore in this week's Terraform Tuesday Terraform Basics. Hey, what's up, everybody? It's Ned Bellavance, Ned1313 on Twitter, and welcome to Terraform Tuesday. This is going to be another installment in the Terraform Basics series. So far, we've already covered things like variables, input variables, and we've also covered modules. This is sort of the mirror to input variables. It's all about output values. So that's what we're going to cover in today's video. Before we get into that, just two quick things. Number one, if you haven't signed up for my Patreon, it is available down in the description, and for $2 a month, you can get a weekly newsletter, and if you bump up to the next level, which is $5 a month, you get your name in the credits for every Terraform Tuesday video. So not a bad deal. Please check it out and support if you can. If you can't, I totally get it. The other thing I want to mention is my Terraform certification guide has officially been updated for Terraform 1.0, the GA of Terraform 1.0. So if you're wondering if all the cool new bells and whistles in 1.0 are included in that certification guide, they are. I don't know how much the test has been updated to include those, but as the exam evolves, my certification guide already has it covered. So you can check out that. There's a link down in the description as well. With that out of the way, let's talk about Terraform outputs. All right, if we're going to talk about outputs, the first thing we need to talk about is the module-based structure of Terraform. Now, I did a whole Terraform Basics on modules, and I'll link to that so you can find it. But if I could just break it down real quick, a Terraform configuration is encapsulated inside of a module. And if you're working with the configuration in the current directory, that is going to be considered the root module. The root module can invoke other modules, which we'll call child modules, and those in turn can invoke other modules, which would be child modules of those modules. The invoking module is referred to as the parent module. So the root module could also be the parent module for any child modules. Now, why am I talking about modules so much? The reason is that we can think of a module as an individual unit in Terraform. The way you get information into that module, we squeeze it in there, that is done through input variables. And I covered those in the Terraform Basics. That's how information gets into the module. But how do you get information like out of the module? Like get out of there. How do you get information out of the module? The way that you do that is with outputs. So that's essentially what outputs are for. They're to get information out of a Terraform module. Okay, so now we've got that pretty well covered. I think we understand what the purpose is behind them. But that begs the question, what are the use cases behind outputs? Okay, there's three primary use cases behind outputs. The first one is fairly obvious the first time you use Terraform. If you create an output and then you run Terraform apply, boom, that output is displayed in the console screen. You see the output. So that is the first and very tangible reason you would use outputs, is to get information printed out to the screen. Now, the nice thing about that is there's a separate command called Terraform output, and that will just give you a list of the current outputs and the values of those outputs in your Terraform configuration, whatever configuration you're currently working on. You can also add the -JSON argument to that command, and now it will print it out in JSON, and you could use that and pass it to a script or something else to parse that JSON and do something else with that information when your Terraform run is complete. Another important thing to note is that output values are stored in Terraform state. So the output values don't exist until you've run at least one Terraform apply, because that state data doesn't exist until you run at least one Terraform apply. So if you just run Terraform plan, there's not going to be any outputs because it hasn't actually done anything yet. So that's another important thing to keep in mind. Okay, so we have one use case, right, where we want to get information from Terraform either to the screen or pass it along to a different program. All right, use case number two is getting information out of a child module into a parent module. When you invoke a module in Terraform, Whatever happens inside that module it's kind of like a bit of a black box. You pass information in with input variables, but you can't then reach in and access the attributes of any of the resources that are inside that module. Instead, those attributes and values need to be exposed to you via an output. So if you're writing a module, you want to think about what information someone invoking that module will need and then expose that information as outputs. Now, it doesn't have to be an entire resource. You could expose just a portion of that resource. Maybe you're creating a network and you just want to expose the subnet IDs as opposed to everything about the subnets that are being created. You can do that. You can also transform the information before you give it back. You don't have to give attributes of resources back. You could convert those attributes or combine them into a list or map and then hand that back as an output. So outputs support any data type that is supported within Terraform, and you can massage the information you give back depending on how that module is intended to be used. Okay, so that's the second use case. I want to get information out of my child module and hand it back to that parent module. Okay. Use case number 3, let's get into that. Use case number 3 is you're going to use remote state as a data source for another Terraform configuration. It's not uncommon to have one Terraform configuration set up something in your environment and then have another portion of your Terraform, another and separate Terraform configuration leverage some of that infrastructure. And it can get information about that infrastructure by accessing the remote state of that first configuration as a data source. Now, how does it get information out of that remote state? The remote state data source only has access to the outputs that are created by that configuration. So if I'm building a network with one configuration and I want to expose the list of subnets to a separate configuration so it knows what subnets to use, I can do that by creating an output in my network configuration, and then that output will be available to the web app configuration or whatever's being deployed against that network. And this works for a number of different use cases. So now we have 3 different use cases here. We have getting information out of Terraform to the terminal or another program. We have getting information from a child module up to the parent module. And then we have passing information from one Terraform configuration to another via the remote state data source. Okay, now that we understand all that, let's talk about output syntax. The syntax for output it's really simple. You use the keyword output to define an output block, and then it needs a name label by which you will refer to the output. Now, an important caveat with name labels in general, and something I discovered specifically about outputs, is you can't start a name label with a number, a digit. Terraform doesn't let you do it. And this goes for resources, data sources, anything that has a name label, also called an identifier. I don't really understand why they make some mention of confusion. I've never been confused about it, but there we are. The reason I discovered it is because I was trying to have my outputs printed in order by using a 1-2-3- prefix on my outputs, and that threw an error back, and I had to use A-B-C to name my outputs instead, because it orders them alphabetically in the screen output. Now, that doesn't generally matter if you're passing it to a program or to a parent module, but in my specific use case for a demo, I wanted them to be printed out in a specific order. But whatever. Anyway, so just know that you can't start an output name with a digit. Okay. Anyway, so we got our name label. Next, we have what goes inside the curly braces, and it starts with a value. The value is the value you want to return back to whoever's invoking that output. And that value, like I said, can be any supported data type within Terraform. So that could be a complex object, or it could be a simple string. Doesn't really matter. Older versions of Terraform, I believe pre 0.12, only supported strings. So that made it really difficult. If you wanted to get complex information out of a module and pass it to a parent module, you had to turn it into a string, and then the parent module had to know to take that string and convert it to whatever the complex object was. It wasn't pretty. Don't have to do that anymore. So That's kind of nice. Anyway, so you have the value, and then there are 3 additional optional arguments you can add to the block. One is description. Description is good for child modules. If someone's going to be consuming that module, it gives the user some information about what that output is meant to do, what information it's meant to convey. So definitely fill that out if you're writing modules to be consumed by someone else. The next argument is sensitivity or sensitive. And sensitive is there to mark the value as sensitive, which means that Terraform will not print that value out in the terminal output, and it will also not log that value to any logging you have enabled. The value will still be stored in state, so it's still stored somewhere in clear text, but it will not be part of your logging or your terminal output, so you're safe from those 2 potential liabilities. So if you're printing out something like a password or an API key, make sure to mark it as sensitive. The last one is depends on. And usually Terraform is pretty good about figuring out dependencies using its graph. But every once in a while, you'll fall into a situation where there is a dependency, but it's not obvious. And the way that you can explicitly say there is a dependency is by doing depends on, and then you can have a list of things that this output is dependent on before Terraform will try to render the output. Now, like I said, if you're referencing another resource, Terraform knows intuitively that it has to render that resource before it can render the output. But if for some reason it's not an obvious connection between the resource and the values in the output, then you might have to use depends on. Okay, so those are the meta arguments, or those are the additional optional arguments. Now let's get into a demonstration of the 3 use cases I talked about earlier. Okay, here we are in Visual Studio Code, and if you're looking for these files, you can always find them on my GitHub repository, Terraform Tuesday. Today's folder is 2021-08-17-outputs. That's what we're going to be working with here, and I've got 3 folders for the 3 different use cases. We're going to start out with terminal output. I also have a nice README here that kind of takes you through the things I just talked about in case you're curious. So we'll start with terminal output. Let's take a look at what's in the main.tf file. Okay, so I'm defining a few different local values here that I can work with for my outputs. So I've got a basic string value, a list value, and a map value. Okay, and then I'm also generating a random integer that I can use for outputs as well. Now, how am I supplying my outputs here? Well, the first output is simply my string. The second one is my list. The third one is my map. And the point of this is to show that you can pass complex objects as values in outputs. It doesn't have to just be a string. And then the last one, I wanted to show that you could pass an entire resource as opposed to an attribute of that resource. So I'm doing that by setting the value for random out to random integer dot random. That's the resource itself, not any of the attributes of that resource. So let's open up a terminal here, and we'll go into terminal output, and we'll simply run, I've already run Terraform init, so that's done. If you're following along, I've got the commands right here. We're just going to run a Terraform apply auto approve. And as I said before, you won't see anything in the outputs until you've run an apply. Okay, so we just ran the apply. Let's see what outputs were printed to the screen. We have my list out. Okay, so it printed out a list. We have my map out. That looks an awful lot like a map. We have my string out, which gives us our string. And then you can see the random out actually gave us a pretty complex object because it has to include all of the attributes of that resource. So it has an ID, keepers, max, min, result, and seed. This could be really useful if you're trying to parse the information by passing this object to another program or something that understands JSON. Now, how do we do that? We can use the Terraform output command to print out our outputs whenever we need to see them. So if I just run Terraform output, I get my outputs again. It's just that simple. Now, if I add this dash JSON, instead of printing it out in this human readable format, it instead will print it out in JSON format. Okay, so now this is in JSON format. This is something that a script or a program could easily parse through. We can do that with JQ. So if I pass that same command to JQ, I can access something specific about it. So let's just run this real quick. And there we go. Now it has been passed to JQ, and you can see it's nicely formatted with color coding and all that jazz. It makes it a little easier to read. Now, if I want a specific value out of there, let's scroll down. Maybe I want the resultant value from my random resource. Well, I see that I've got random out, so that's where I start. And then the value I'm interested in is stored in the value map. So I'll expand the path with .value. And then the actual value I want inside there is result. So I'll finish the path with .result. So I'll go ahead and run that entire thing down below. And there we go. There's my result. So if I was parsing this with JQ or with a script, I could do that, and it works pretty well. Okay, so that is the first use case for outputs using the terminal or passing it to another program. In our second example, we're going to take a look at modules, and we're going to have a child module and a parent module. The parent module will be our root module, and that's all stored in the modules directory. So I'll expand that out, and you can see we've got a main.tf file. That's our root module, and it's going to invoke the salsa module as a child module. So why don't we start with the main.tf of our root module and see what's being defined here. So I've got some variables. I'm basically trying to make a taco, okay? And I've got some variables defined here. And then I have a module called my salsa. That's the name label I used. And I'm sourcing it from that local directory salsa. And I'm passing it one input variable, meat. And I'm setting that to whatever variable I use as meat. And then I can go into, let's go into the salsa and see what's in this child module. All right, in the main.tf there, it's a very simple module. I have one variable input and I'm supplying that, it's meat. And then within locals, I create a local map called salsa. And salsa maps a meat to a salsa type. So maybe if you're eating fish, you'd rather have pineapple salsa. Who knows? That's what this is intended to do, is marry up the meat with the proper salsa. And then for the output, you can see the description. I have a description that explains what it is. And then for the value, what I do is take the variable meat and use that to look up a value in the salsa map in my locals value. So local.salsa, that's the local value, that's a map. And within there, find me the value that corresponds to the key of the meat that I've submitted. That's what I'm returning as output for this module. Now let's go back to the main.tf module and see how I'm consuming that. In the main module, in the root module, I have a locals taco map here. And you can see for my taco that I'm constructing, meat, cheese, and shell all get their value from the variable. But the salsa I need to get from my module. So you can see the way that I reference the module is by doing module.mysalsa, so that's the name label of the module, and then the name of the output I want to reference. In this case, the output name is salsa, so I do .salsa. And that's how I retrieve that value from my child module. And then for the output for the root module, I'm simply going to print out this map by doing local.taco. So let's take a look at it and see how this runs. All right, so I'm already in the modules directory. I've already run Terraform in it and gone through all of that. So I can pretty much just run Terraform apply. So I'll go ahead and do that now. Terraform apply, auto approve. And the default value for meat is chicken. So we can see when I ran that, the meat is chicken and the salsa is tomatillo. If I try it with a different meat, say beef, for instance, let's go ahead and run that. We can see that the meat is now beef and the salsa changes to picante. So you can see that the output returned from the child module is dependent on what meat I submit as an input variable. So hopefully that gives you an idea of how outputs work for a child module. Now for the last one, we're going to take a look at how I can pass data as output from one Terraform configuration to another. In this last use case, we're going to see how we can pass information from one Terraform configuration to another using the remote data source and outputs. Now, in order to do that, we've got two separate Terraform configurations in the remote state directory. Let me expand that out. We've got a network configuration and a web app configuration. The network configuration creates a VNet in Microsoft Azure, and then the web app is going to want some subnet and resource group information about that network, that VNet that's been deployed, so it could deploy its own web app. Let's take a look at what's in the network configuration. All right, so I'll go ahead and open up the main.tf here. As you can see in the back end, I'm using Terraform Cloud to store my remote state data. And this is the same state data that the web app is going to need access to. The organization is Ned in the cloud, and the workspace is Terraform Tuesday modules setup. I've already created that workspace. And in order to successfully deploy something to Azure, I had to give it some credentials. So I created 4 environment variables and added those to the workspace. So if we look in commands.sh, these are the 4 environment variables you would need to create in your workspace, and they map to an Azure service principal that has permissions to create the VNet. That's a pretty straightforward process. I've definitely covered it before, so Google it or whatever you need to do. It's pretty easy to create that service principal. Going back to the main configuration, we scroll down a little bit here. Let's get down into the actual resources that are being created. I've got an Azure resource group that is going to hold my virtual network, my VNet. And then I use the Azure network module that's on the Terraform registry to create my VNet. So I have a root module now that is invoking a child module. That's the Azure network module to create my network. Now I want to get some information out of that network child module and make that available to other configurations. How do I do that? I do that through outputs. So I have 2 outputs here. One is called subnet prefixes, and this will give a list of VNet subnets. Now, the way that I get that information is I have to get one of the outputs from the child module that I'm using. So I use module.network.vnet subnets. That's the name of the output that will list out the VNet IDs. And then separately, I want to get the resource group name. So I create that as an output. And that one, I can simply reference the resource Azure RM resource group.vnet and the attribute.name. That's the attribute I want to be made available as an output. So that's everything that is in my network configuration. If I go ahead and open up the commands here, we're going to run an apply on this network configuration. So I'll open up my terminal, go into network, and go ahead, and I've already run Terraform in it. So I'm going to run Terraform apply auto approve. And this will also, I've actually already deployed the network, so it shouldn't make any changes. It's simply going to print the outputs once again. So there's a couple different ways to get access to outputs. You can run an apply that doesn't make any changes, or you can use the Terraform output command. Now, once that's completed, we can go into the web app folder and see how that's going to access the remote data source. Okay, so that has completed its run. It sees there's no changes necessary. So next, it's going to just print out the outputs and be done with its run. All right. Oh, it didn't even do that. Well, in that case, let's go ahead and run Terraform output so we can at least see what information's in there. All right, Terraform output, it gives us our outputs here. We have our resource group name and our 2 subnets that were created by this module. All right, so this is the information that I want to make available to my web app. Let's go ahead and view how the web app is handling that. I'll expand web app here and look at the main here. And like I said, this is a data source. So the first thing I have to define is a data source of Terraform remote state type. And I'm going to call it network because I'm getting network information. Now, you have to tell it where it can find this remote state data. So I have to tell it what backend type is being used. In this case, it's remote because I'm using Terraform Cloud. And then in the config block, I have to tell it what organization and what workspace is involved that it needs to go out and access. Now, it's going to use my Terraform Cloud credentials to do that. So it should be able to go out and access the same information that I just used to deploy my network. And then you can see the way that you reference something from that remote data source, I am outputting the resource group name, the subnet prefixes, And I also want to show all outputs. The syntax for referencing that remote state data source is data.terraform remote state dot the name of your data source, which I called network, dot outputs dot whichever output you want. Now, dot outputs is an attribute all by itself. It's simply a map of all of the outputs that are available from that data source. So you can directly reference one of those attributes or one of those outputs, like I am with resource group name. Or if you see down at the bottom for all outputs, I'm just doing dot outputs, and that will give me every output that is available from that remote data source. Okay, so that's everything that's in here. I'm not actually creating the web app. I just wanted to show how you can get access to that information. So let's go ahead and open up the terminal again. We'll go into our web app folder. And for that one, I'm simply going to run Terraform apply auto approve again. It's going to go out, check that remote state data source, and then it'll print everything out as outputs. So we can see we got our resource group name. We have our subnet prefixes that matches up with what we saw before. And if we scroll up here, we see all outputs is actually a map of all the different outputs that are available. And there's only two, resource group name and subnet prefixes. If I defined additional outputs back in my network configuration, those would show up in the all outputs for my web app configuration. So that is the third use case that you can employ for outputs. All right, in this video, we covered outputs extensively. I hope you have a pretty good understanding of what outputs are and what they are used for. We covered three use cases. One is sending the data to the terminal or another program. The second was sending information from a child module to a parent module. And the third one was sending data from one Terraform configuration to another. So those are the three primary use cases for outputs. And we saw how you can use it in all three cases. All right, that's going to do it for me for today. I want to first say thank you to the patrons out there for supporting this and my other projects. It's very much appreciated. If you want to sign up, like I said, a link is down in the description. It starts at $2 and goes up from there. If you sign up for the basic $2 level, you get a weekly newsletter of everything that's going on with Ned in the Cloud. So definitely check that out. I also want to have a quick shout out to my podcast, Day 2 Cloud. We've been doing some great episodes lately, and I know the one that drops this Wednesday with Chris Nova is going to be extra special good. So definitely check out the Day 2 Cloud podcast. There's a link in the description to that as well. That's going to do it for me for today. Thank you so much for watching. If you don't mind, if you could subscribe, I'd really appreciate that. Until next time, stay healthy, stay safe out there. Bye for now. Okay, you might have noticed that the sign wasn't on for the whole beginning of this video, and that's my fault. I kind of forgot. I have a remote, and I'm supposed to use it, and I just completely forgot. So, oops, these things happen, but I need to get these out every week. So sometimes you got to leave the mistakes in and just enjoy them. So that's your Easter egg for today. Enjoy the fact that I forgot to turn on my sign. All right, bye.